Well, hi everyone. I'm super excited to be on this panel with really, really amazing folks over here. Kay, it's nice to meet you again. We got to meet on a project together. So I'm Aishwarya Srinivasan. I'm part of the Fireworks AI team. I come from a data science background, and I'm currently leading the AI developer relations team at Fireworks. And a lot of you have seen you, heard about you, seen your work, and it's very exciting to meet you in person and have this conversation with you. It's obvious that we have in the last few years we have seen a really huge increase in the number of companies not just using AI, which is the top layer of AI applications, but we have also seen a lot of companies which are going deep till the infrastructure level. So that's where Grok is building ASICs for doing that. So it's very well understood that people are understanding of going to a very, very deep level and optimizing for infrastructure, understanding that, hey, GPUs worked great for most of the AI applications. We were trying to use it. We're still optimizing it. That's what we're doing at Fireworks. We're optimizing running the generative AI models on GPUs. But there is a need, or there is an opportunity for you to see that we can optimize the hardware, and there is something to do there. And what was Grok's thought process there, and what are you seeing currently when it comes to developers using it? And when you see that people are seeing the opportunity, people are trying to move their workloads into Grok, what's your thought process around that?
Amazing. So, hi everyone. My name is Hatice Ozen. I'm head of developer relations at Grok. I've been here for about 4 years. Before I answer, actually, how many of you have heard of Grok or used Grok? Grok with a Q. Amazing. Years ago, that number was 1, maybe. So this is great to see. When it comes to hardware, so as we know, since the birth of ChatGPT and that kind of going into the mainstream and everybody using it, even being talked about at dinner tables, we've seen that AI is going to be here and stick around. And there are certain use cases that you just cannot unlock with the legacy hardware that we have today. So of course we have GPUs, but GPUs are just not enough for real-time use cases. So I know that a lot of you have probably used OpenAI or ChatGPT, probably everybody in this room. You know that when you ask a question, you see the tokens or the word streaming, right? Which is enough for our human eyes. But there are things, for example, in the financial sector, when it comes to healthcare, when it comes to monitoring, that needs to happen real time. And then especially now that people are putting AI agents into production and we've moved on from the research stage, there are so many operations that happen in the back end, such as web search, all of these dozens of tools, MCP servers that you connect to your large language model, which is the brain. And legacy hardware is not enough. So with that in mind, we have the LP, or the language processing unit at Grok, and it was just purpose-built for AI inference. So you have a custom solution where you can get thousands of tokens per second and actually enable real-time use cases. And you don't need to buy hardware for this. Thankfully, we have done the hard work of building out 10 data centers in the past year globally. We have another launch next week, and you can actually access this via Grok's OpenAI compatible APIs. And I think it's really important as you look at LLMs. I know all of us are trying new models out there. A new one was just released by Moonshot AI, Kimi K2 Thinking. We need to really diversify not only our models, but consider performance, cost economics, and diversify the infrastructure layer so that you can make sure that you're not just going to another provider and it's just another GPU-based solution, which you may not need.
Thanks a lot, Hatice. I love the fact that you focused on the latency as one of the core pain points that you're seeing when people are trying to scale AI workloads, right? A lot of times when I'm speaking with people, that's not the only primary concern that they have, especially a lot of startups who are just getting started, building prototypes, a lot of research labs. till the time that it's actually going into the hands of millions of users at a time, latency sometimes isn't the only concern that people have. So Michael, like, you're probably working in the amazing cross section of research as well as academia, as well as like industry expertise. So based on your experience, what are some of these major challenges that you've seen? And this is probably going to come to the other, like Kay and Josh you as well. So Michael, do you want to talk to us about that?
Yeah, so first of all, just by way of introduction, I am first and foremost a machine learning researcher. Started working in the field in the late 1980s in graduate school. So suffice to say, I've seen a lot of change. And I've been spending most of my time the last 6 years at AWS, at Amazon, in various AI-related activities, but especially around responsible AI and related topics. And so one of the things as an academic and researcher that kind of took me a while to absorb at AWS is just the emergence of what I would call like the AI supply chain. And so it's not that I don't think that hardware, software, all of this sort of technology stack of AI isn't, that there's not more optimization and integration possible, but I think the thing that's immature in the industry is that supply chain. And by that I mean, cloud developers like Amazon, Google, et cetera, deploy AI models at scale for our enterprise or consumer customers. But then there's a whole ecosystem downstream from that, right? There are developers that are building on top of those general purpose projects. There are startups downstream from that that have their own end users and consumers. And there are just so many inefficiencies in that supply chain. And I think part of that has been exacerbated by generative AI, that in a very short time, the pendulum swung from, like incredibly targeted ML applications, things like face recognition or specific models for medical diagnosis or the like, where you really knew exactly what your use case was, what it was you were trying to predict. And suddenly, like in less than a year, we have these incredibly general purpose models that sort of nobody knew what to do with at all. And this, of course, now we have the agentic era where this is happening again. I personally think that pendulum has swung too far, because when you really know what you want to do, you're better off building a targeted predictive model for exactly that thing than specializing a more general, powerful model to that thing. But I think, in my view, the thing that's sort of least mature about the industry are the connections between those supply chains. So for instance, it is very difficult at AWS in our AI division to anticipate all the possible downstream use cases of either our targeted or our generative or our agentic models. And so that's going to introduce inefficiencies. And there are reasons for these inefficiencies, right? I mean, there are contractual reasons for it. For example, like at AWS, our customers' data is private to our customers, it's secure to our data. We can't fine tune our models on their data without their permission and without their cooperation. And so I think that the next kind of big advance that needs to happen in the field is to find ways of making that supply chain more efficient.
That's really interesting take, especially something that I don't come across a lot. So thank you for sharing your thought process around that. Okay, you're working on a very cool tool which I use a lot. So from your perspective, like when you are building agentic AI toolkit, and you have spoken about this multiple times, it's a multi-agent system, you're using mixture of agents. What is the biggest bottleneck that you have seen in order to scale these systems?
So thank you for having me. My name is Kay. I'm CTO and a co-founder of GenSpark. So anyone here have used or have heard about GenSpark before? Not a lot of people. So I give a quick introduction. GenSpark is an all-in-one AI workspace. We try to bring the kind of cursor or cloud code-like experience for software engineer to normal white-collar workers. That's what we are building. And we have a bunch of kind of different type of agents, just like Ashi mentioned. We have AI spreadsheet, AI slides, AI document, this kind of office suite. Also, we have the AI employee, like the AI designer, AI developer, and so on. So currently, the bottleneck, we don't really see a lot of bottleneck, because in GenSpark, we are trying to build in a more AI native way. Because I talked to a lot of people, and I found that basically there are two kind of mindset these days considering AI. One is the more critical mindset. It will say, okay, AI is not good for this, it's not good for that, and we cannot trust it for certain type of tasks. Another way is the AI native mindset. Basically, we are trying to find, okay, what AI can do right now and can do it reliably right now. And since everything is happening very, very fast these days, every month, every week, there's a new model coming out. So our team in GenSpark, our team is trying very hard to, build on the borderline, on the boundary of the kind of the frontier model. And we are actually observing this the thing that the current model can stably do is actually expanding very quick every day and every month, every week. So we are launching a lot of features very fast. We almost on a weekly basis. We will have a very rigid and a very strict internal evaluation process to make sure, okay, everything we delivered actually have very good quality and is reliable for users. But if you look at GenSpark, you will find that more and more things can be done by AI nowadays. And we are trying to deliver it to more and more people. Yeah, that's what we are doing.
That's lovely. And Josh, would love to get your thoughts on what are the biggest bottlenecks that you're seeing. Google is pretty much building an ecosystem. You have the models, you have the hardware, you are running on GPUs. You have pretty much like all the pieces of that block. So what are the biggest bottlenecks that you've heard from developers who are trying to build AI systems on Google Cloud?
Yeah, thanks. Thanks for having me. So good morning. My name's Josh. Been in the AI space a long time as well, mostly teaching a little bit of engineering. So I think the biggest challenge to breaking the limits of AI growth is really the community. And let me explain what I mean by that. So as a bit of a side project, but like one that I'm very passionate about and something I care a lot about is healthcare and helping really brilliant people in medicine develop applications that are useful to people like me who occasionally go to the doctor. And I think sometimes in AI, we see the strongest results when we pair people with expertise like all of you have in this room. So an understanding of AI and the ability to build systems with people who have really important problems and important data. And I think we have a tremendous opportunity in 2026 because the entire world is aware of AI now. Everybody's eager to try it out, but we have a lot of people who can call models, but there's much more involved in actually building a system that's really useful in practice than just a couple lines of code. So I'll give you a couple examples from the work we have at Google. So one thing we're investing in is we call it full stack AI. So at the widest level, we have models like Gemini, which are LLMs as a service. You can call them in a couple lines of code. We also have openly available models like Gemma that you can download, you can fine tune on your own hardware, GPUs or TPUs. They're your model, you can rock and roll. Going down from that, we have open source frameworks, things like JAX. We're investing more in PyTorch on TPU support. We have things like Keras and Keras Hub, where you can actually develop your own models. And then even further down the stack, we have on-device machine learning with something like LightRT, where you can deploy models that you've trained on device. And just in the last couple months, I can give you a couple examples just using the healthcare community as just one example of important projects that our collaborators are working on using these different frameworks. So with on-device machine learning, we're collaborating with Harvard Medical School, basically to build like an ophthalmology model to screen for eye disease challenges, but then to deploy it privately on device. Moving up, like from on-device to something like JAX, we're working with people who are actually training their own foundation models from scratch. So Stanford has the Marin project, which is fantastic. It's a foundation model they developed in-house and trained on their own data from scratch. It's great. That actually outperforms open models, some variants of Gemma and some models from other companies too. Totally open, which is really cool. Moving up also Children's Hospital of Philadelphia is doing something similar. I'm from Philly, so this makes me really happy. They're training foundation models on patient data so they can reason better over the folks they have. Moving up the stack, like very briefly, like with models like Gemma, we have a collaboration at Cedars-Sinai, and they're trying to train an in-house model to predict next events in the emergency room. And then with a really widely available model like Gemini, the sky's the limit, and you can get started in seconds. But really the critical thing is that taking the skills that you have, understanding AI and how to use it in practice, and finding collaborators in different fields. It doesn't have to be healthcare, it can be economics, climate science, anything you can think of. And the sky's the limit. So it's really the thing that I think about is how can we take the skills that we all have in this room and make them basically generally available. So that's the top of mind for me. So yeah.
Josh, I really like how you explained the entire ecosystem that Google brings in, and which is something I also find very fascinating, that you're dealing with all the hardware, like you have your TPUs, you have your hyperscaler, you have your models, you have your frameworks, everything in one place in an ecosystem. So from your perspective, I would love to understand that when you're building products which may not be super niche, when you're trying to target multiple different industries, multiple different personas, whether it is developers building a startup prototype where they're building out some products, versus when it's enterprises or more mature startups building scalable products. How do you make those product decisions? Like, how do you know that we need to target this entire spectrum of users with the suite of products that you have?
It's a great question. So my role at Google is developer relations. So the way that I think about products is, you brought it up, is from the DevRel lens. And what the DevRel lens, it's really, everybody thinks about it in different ways, but in my mind, there's three things. So there's developer experience. So the most important thing is making something that's easy to use and works really well in practice. The next is education. So like a side project I have, we have a lot of really brilliant engineers at Google who have vastly more depth than I will ever have in my life. And so some things we work on is bringing their expertise out into the community. And this can be like recording tech talks and putting it on YouTube, and then building community. And so I think to your question, the challenge is, as we all know, AI is the most horizontal technology we've ever had. It's like electricity, and it touches every single vertical. And so it's very difficult to reach them all individually. And that's why, when I think about building products, it often goes back to the community. So not to be like a broken record, but I've been beating this horse. It's really, how can we scale expertise into these different verticals? Because we have general purpose models, anyone can use them across any field in seconds, really, or minutes. But it's really helping them understand. I've got a friend who's a prof at a small liberal arts college in Philly, brilliant guy, teaching nutrition. But he would love to use these models for teaching assistants or help him grade papers. But he's a nutritionist, and he's got a PhD in nutrition. He can call the model, but he's not a programmer. He doesn't have the experience that you do, and he just doesn't understand how to prompt it to make it do something useful. So it's really focusing on helping the verticals understand how to use the products, because the products themselves are general purpose. And that's the very unique moment in time that we're in 2026, or about to be.
That's actually a very wonderful point that Josh mentioned out, right? Right now, we are in a place where even out-of-the-box solutions does solve a bare minimum benchmark of what it can do from a general purpose perspective. The out-of-the-box model is good enough for you to even do that API call with a bunch of prompt engineering and call it a product prototype. But with GenSpark, we're working on supervised fine-tuning. Fireworks is doing supervised fine-tuning and RFT with you. That's something that we published about. So it's a very common use case that we are seeing with companies or startups go beyond that benchmark, which is hey, it was so good with the general purpose model, whether it was open source or closed source. But for us to go to the next level where we can really call that our product plus product which is using model and the data that we bring in is our moat, we need to start thinking about customizing the models. So you are using mixture of agents. We spoke about that. So tell us more about what was your thought process on fine-tuning the models?
That's a very good question. So in GenSpark, we actually produce all kinds of output. So not only the text output, like the result of the deep research, we also produce slides, we produce video, we produce image, we produce all kinds of stuff, produce all, podcasts and so on. So we don't really rely on the normal kind of standard benchmark, in the industry benchmark, to do that, to decide which model is good and which model we should change to or shift to. So we actually build a kind of, we call it grader, or a very important evaluation tool inside to evaluate all kinds of output that GenSpark generates, whether the slide is good, whether the podcast is good, whether the entire agent workflow is actually makes sense. Is actually have all the redundancy in it, and is it kind of easily understandable? So the core of everything is build a very good evaluation platform. And also, since the general purpose large language model is more and more powerful, we actually implement the internal grader using the large language model as judge, because we actually combine all kinds of model to do the judgment. Some model are, for example, like Gemini is very good at the visual. So when we generate a kind of a slides or we generate a report, we will let Gemini to visually look at it to see, okay, whether it's kind of designly pleasant or also. For other type of output, we will kind of have different type of model to evaluate on different type of dimensions. By using all these kind of large language model as judge, we can have a very good grader. And starting from that, a lot of things is actually happening. For example, the reinforcement learning fine-tuning, just as we published with the fireworks, it actually can bring the open source model much better. You know, after the reinforcement fine-tuning, it actually can make the open source model much better than the proprietary model on certain type of tasks, including the two core chains. For example, in the reinforcement learning don't really inject knowledge into the model, but it will get the model be familiar with the tool set you used in the agent. And the model is by trying out a lot of in the environment, the model actually learned how to act on different situations or different scenario, using the available tools to better achieve the final result. So we saw a lot of kind of potential underlying it. But the first thing is what everybody want to do is build a very good large language model as judge grader to evaluate everything output in your system.
That makes sense. And Hadiz, I would love to get your perspective on how you have seen, like we work on similar things when it comes to open source model serving, right? And I personally feel like DeepSeek was one of those inflection points which really opened up the floodgates for people using open source models, because the performance cost equation, which was always better for closed source models, that changed. And they introduced reasoning models. There were a lot of like newer capabilities that you could explore with open source model. And you mentioned about the moonshot also, like releasing Kimi K2 thinking, right? There's always so much happening. There's always so much coming out from the open source space. So what's some of the interesting like things that you have seen that developers talk to you about in terms of like using open source models versus closed source models that they might be experimenting with?
I'll say two things. One, I want to jump off of what Kay said around LLM as a judge and benchmarking. There's been a huge conversation around evals, benchmarks, quality of models, quality of inference providers. And something that actually we're doing at Grok is we open sourced something called OpenBench. You can search this up. It's on GitHub. Check it out. It's basically what we use internally to benchmark all of the models that we have on Grok that we're going to make available on Grok before we release to the public. So as you know, there are a lot of benchmarks and evals out there. Every single time a frontier lab develops a model, they produce a model and they market it. You'll see all of the nice little charts talking about, oh, this is the next new soda model. There's a lot of confusion out there, and there's a lot of vibe testing going on. But I think that the most important for you out there is that you know your data, your use cases, what you're working on at your company. That's the best benchmark you could ever have. So before looking at any of these benchmarks and numbers that say a new model is soda, vibe testing is actually really important. Every single time a new model comes out, I think we all hop in and test them and see what the vibes are. But I think that beyond that, you should be using your internal use cases and maybe swapping the models and seeing if they're better at tool calls, seeing if they're better for your specific domain, and etc. So that's important. And another thing I'm seeing, AI agents are being pushed into production. I think we said 2024, people were just learning about agents. What the hell is an AI agent, right? And now we all know what they are. We're pushing them to production. I think that what I'm seeing a lot of developers talk about again is every single time a new model is released, and I love open source, I think, yeah, DeepSeek was definitely an inflection point, and now we have Kimi K2 thinking, which I'm really excited about as well. That's amazing. It started with tool use and models not being that great at tool use, and us realizing we have LLMs which kind of catch all of the use cases and queries that people could ask, but now we can equip them with our own data, our own APIs, databases, give them basically hands along with the brain being the LLM to actually put workflows into production. So I guess what I would say there is, again, just following along with what's going on in the AI space, even though I know it moves very rapidly. Trust me, I'm trying to be online 24/7. It's not an easy space to be in, but every single time a new model comes out, I would say just looking at that, you do not need to default to the most expensive frontier lab models when open source is getting this great at tool calls and general knowledge. So I would say watch out for that and just know that you can have multi-model workflows ranging from the smallest models for very simple tasks to maybe you do need a frontier lab model if you also want to pay the inference bill for that.
We have spoken a lot about like practices, and just before our panel, we had a panel on governance, and this is something that I am deeply passionate about, and that's why I wanted your perspective, Michael, on this. I started learning about responsible AI probably 8 years ago when I was in school, and still very much academic, you know. And as in when we started seeing more AI toolkits being built and being used by millions of users, when it really started like seeing that traction, that's when a lot of industries started talking about responsible AI. And I feel there is a fundamental difference between how academics see responsible AI versus how industry sees responsible AI. One being more in like ethical side of things, and the other one being more like, hey, is this going to break my bank? Is this going to break my business? So from your perspective, like, where do you see there should be like a consensus? Where do you think like academics need to like get more into applied side, and where do you see like industry needs to get more into the ethical side?
Yeah, these are all good questions. I mean, as somebody who's been working in responsible AI for around 10 years now, and that's about as long as anybody, you know, people in the machine learning research community more or less discovered at the same time that the general population did about the negative side effects of AI. So even before generative AI, it was about 10 years ago that you started reading reports in the mainstream media about a journalist and a researcher getting together and performing like a third-party audit of all commercial face recognition systems and concluding that there was demographic bias. And so this caused, you know, people in the community like me to start working on it technically and, you know, coming at it first from a technical perspective. You know, I think my attitude at the time, and still largely is, that, you know, these are technological artifacts that we have built, and if there's something about their behavior that we don't like, you know, we could think about fixing that in the lab first rather than waiting for harms to occur and be litigated in the courts, for instance. And so there was a huge amount of research done in the subsequent years on this topic. It's now a very vibrant, you know, sub-community of NeurIPS, ICML, iClear, all these conferences. And I felt like we had a pretty good grip on it up until generative AI came out. And so what I mean by that is, you know, I come from a math theory background originally. So to somebody like me, you know, having good definitions is really important. So if you want to sort of talk about training machine learning models that are fair, you need to define fairness, and ideally in a way that you can technically enforce in the training process. So we know how to do that for things like classification and regression, for instance. So again, these targeted models that aren't producing free-form text or images, but are making point predictions, right? So if you tell me that you're concerned that your consumer lending model might have a higher false rejection rate on one demographic group of applicants than another one, we have algorithms now for training models that prevent that kind of thing. If you want models that have some formal guarantee that they won't exfiltrate private sensitive training data, you know, there's a whole area called differential privacy, and we know quite a bit about it. We know how to train neural networks in a way that will obey differential privacy. So, you know, things were sort of going swimmingly there up until around 2023, and then generative AI came out, and a lot of these same ideas are still quite relevant, I think. But the problem from an RAI perspective with things like generative AI, of course, is just the very generality and open-endedness of the output. And so, by the way, I'm the type of person who thinks if you're using a guardrail model, it means that you don't really know what you want. I'm not saying it's a bad idea to use guardrail models, and in many cases they are the best solution that we have right now. But in the same way that I said that we have reasonable definitions and ways of enforcing those definitions of things like fairness in simple classification problems, I have no idea what it would mean for a large language model to be fair in a general sense and in a way that can be enforced in the training process or reliably at the output. And so instead what we do is we train models to avoid stereotyping behavior by having human beings annotate input-output interactions for whether they contain a stereotyping response, for instance. And just to be clear here, if you played around with the early LLMs pre-ChatGPT, like the Da Vinci models leading up to it, when I would experiment at those times, if I typed in a prompt that mentioned, let's say, an ungendered last name in Western society, like a Chris or a Pat, could be male, could be female, it would invariably come back with a completion that assigned male pronouns to Pat. Unless, of course, I said Pat was a nurse, in which case it would invariably, complete with female pronouns. So we handle these things by guardrails now. And so I actually think there's quite a bit of very, very healthy interaction between sort of the research academic community and industry on these topics. It's just that the technical side of it has become much harder in the generative era, and will, of course, the agentic era is going to just clearly raise a whole bunch of new privacy and security issues. Let me just invite you all to think about the fact that when it comes to things like privacy and security, we're very used to drawing boundaries around data sets and saying like, okay, here's the group of people that should be able to access this level of data, and here are the cryptographic keys we will distribute to them to do so. When data is given to an LLM, the first thing that gets happened is it gets mapped into some very abstract embedding space that we don't really understand. And it's not really clear what happens to these boundaries that we draw around data when it gets transformed into embedding space. I think the other piece here is the regulatory governance piece that was discussed in the last panel. This is obviously an area that at Amazon we watch very closely, have opinions about, et cetera. But the big gap for me there as a scientist is every time I pick up a new piece of regulation, I'm reading it for many things, but one of the first things I'm reading it for is, as a scientist or a developer, an engineer, people in the technical side of the industry, is this regulation, is there anything in it that has technical traction that actually would ask you to do something different than the way you do it today? And I haven't seen that piece of regulation yet. Almost all of them, either they say things that could be interpreted as technical, like the GDPR mentions fairness and privacy everywhere. Nowhere does it say what those words mean, how much of them you should have, or how you would measure it. And then the rest of it is largely about process and organization. It's like thou shalt have an office of responsible AI that designs some auditing process, but the details are few. And so I think that gap prevents like a tighter connection between sort of the science side of things, which would generally seek to offer technical scientific solutions to some, not all of these problems, and the sort of industry side, where the focus is often first and foremost on the regulatory landscape.
Michael, I loved the fact that you talked about responsible AI before the generative AI era started. And I feel back then it was companies or people building their own models with their own data or open source data, where you were the owner of the model. This was before model as a service came in picture. And I personally am an advocate for open source. So it's not an easy question that I'm going to ask you. Do you feel open source models are safer than proprietary models?
I don't really have a strong opinion on that. I'm a huge supporter of, I'm a computer scientist by training. I've been in the field for decades now. Betting against open source is always a bad bet in the long term, I think. That doesn't mean that proprietary models can't exist alongside open source, but every effort to quash open source activity in the history of computing has always eventually failed, maybe the internet itself being the prime example, and efforts in the early internet to have tiers of service for packet delivery and things like this. These things, they always die, right? And so, my view on this is that, whether it's open source or proprietary, I think just RAI has become a more challenging area for the reason, that people have been discussing here of downstream specialization and fine tuning of models. Like, imagine that you bought some new electronic device, but the makers of that electronic device didn't really clearly understand how you might use it. So, you're not quite sure whether it's going to work with your Wi-Fi network, with your Bluetooth, whether the electricity in your house will be compatible with it. I mean, none of us would think that this is an okay state of affairs, but that's sort of the state of affairs with generative AI. And I completely agree, you need to test for RAI principles on your side, on your own data. But this is kind of heavy lifting for all but the largest kind of entities in the industry. So I don't think it's more of an, open source is more or less responsible than proprietary. I think just the problem is becoming difficult and it's requiring more and more technical expertise downstream from the big developers of the technology.
Thank you. Thank you so much for sharing your perspective. Well, going to the three of you, I would love to understand, what's that one thing that you're excited about, and where do you feel that the industry is headed, in the sense that we have seen breakthroughs with reasoning models, we have seen breakthroughs with open source models, we have seen breakthroughs with vision models, with VO3, or all of these models. We have seen that constant growth, and a point where people would say that, hey, a model can never be good at creating hands, or it's never going to be good at creating a video of a gymnast. We have gone past that stage. So in the next 6 to 12 months, what's that one thing that you're super excited about and you're betting on?
Yeah. So as a software engineer, maybe I want to dream bigger. So I'm very excited. If it happens, I will be very excited is if the large language model can help accelerating the large language model research. That will be very exciting. Because currently, as a software engineer, we work in a very small team. We will feel actually we are super empowered by the cursor, by the cloud code, by all these things. It helped me write code much faster, build things much faster. But if we reach at some point that the frontier labs model can actually help the frontier lab research faster to bring up better model, it will kind of enter the tipping point. So it's maybe a little bit scary, also very exciting as a software engineer. I hope to see it, but safely.
At first, I was thinking robotics and AI. That's going to be interesting. But you said the next 6 to 12 months. So I want this might be.
1X launched their humanoid robot, Neo.
I'll need to check it out. And I don't want to be the first customer of these things because it's probably not going to really work.
Never try
well.
the V1.
Yeah, exactly. But I would say a lot of governments are now racing for data sovereignty and really just putting their stake in the AI game. Never thought I'd be really interested in that, but it's very, very exciting to see them, step up the pace. And all of these different governments internationally are talking about AI roadmaps and how they are going to, take AI, which a lot are saying is the new electricity. And I think one of us said that on this panel as well. So it'll be really exciting in the next 6 to 12 months to see who heads where and what policies are going to be emerging from all of this.
Josh, what's your thoughts?
Yeah, great question. So going back to healthcare very briefly. So a lot of the stuff I talked about earlier is clinical applications. And this is stuff we know how to do. So very hard technically, but it's let's train a foundation model on text patient data, maybe even multimodal patient data with some images. The frontier, I was talking with a prof at a Penn, because I'm Philly, go Philly. And she's actually researching a kidney function. And so what she's interested in doing is training a foundation model, not just on text from patient records, but on genomics data. So it's how can we use these models to enable the next generation of science, so in addition to doing stuff that's clinically valuable, actually understand kidney function in a way that we haven't been able to understand it before. So that might not be a 6 to 12 months thing, but I think that's something that the field of generative AI and large models might enable in the future, hopefully.
Might be exciting to see that in 6 to 12 months, the speed at which we are growing.
It's possible.
Well, thank you so much. That's all I had for all of you. Thank you so much for sharing your thoughts, and thanks a lot.